Urban Networks: Rethinking the City is our research paper providing in-depth analysis on the current urban transformation taking place around the world and solutions to key challenges presented by this mass urbanization. In this video, we provide an overview to the contents of the paper. The data on urbanization is in, and it clearly reveals that we are currently engaged in an intense process of transforming the environment within which humanity lives. Over the course of a century, from 1950 to 2050, we are transforming our environment from a natural rural habitat to an engineered urban environment, as we move from an urban population of just 30% to one of as much as 70%. This is a process of huge transformation, disruption, and development, a process the bulk of which will largely be over within a few decades from now. But how that process plays out is of critical importance to the future success of the global economy, society, and environment. We are living at a time where in principle we could, as never before in history, improve the quality of life for the majority of people around the planet. But the challenges of realizing this are immense, and the perils of fast-paced mass urbanization are becoming ever more apparent. Achieving sustainable solutions within our urban environment is both a huge challenge, as it is systemic, inherently complex and multidimensional, but at the same time, it offers huge leverage in our capacity to shape our future environment at a scale and speed never seen before. But the challenge of urbanism today is not just one of scale, speed, and scarcity of resources, but with globalization, advances in technology, and environmental degradation, the equation has got greatly more complex in just the past decades, necessitating a paradigm shift in our thinking and systemic responses. The scale and demands of the process that is underway far outstrip the resources and capacities of the model and structures that are currently being applied to respond to it. Incremental approaches based on traditional ways of thinking and acting will be limited in capacity within this new context. The current model for urban development we inherit from the industrial age. It is one that is based around the mechanics of centralization and batch processing to achieve economies of scale. Mass societies require the mass provisioning of services, and we achieve this scale by breaking the system down into discrete components, separating them into different functions, and concentrating similar functions within centralized locations in order to reduce unit costs through mass production. Housing in one place, education in another, offices concentrated in business districts, production in industrial zones, etc. We then connect them all, typically via personal transport. This centralization of functional domains enables standardization, batch processing, and reduces the unit cost of service provision. However, this centralized model has limitations. Most notable among these is its limitation of scale. Centralized hierarchical structures have both an upper and lower limit to their effective operations, what is called the Gaussian ceiling and Gaussian floor. Below a certain scale, there are too few resources for it to be economic to develop formal centralized systems. The result is the development of poorly organized informal systems. Above a certain scale, the system becomes overloaded because of the bottlenecks created by centralizing resources. The result is congestion and fracturing, creating diminishing returns. With the ongoing developments of globalization, we are currently in the process of trying to scale our economy from providing for the approximately 1.2 billion people in developed countries to the other 6.3 billion people on the planet. This is a huge scaling up process currently taking place, as cities are becoming megacities. Infrastructure projects are becoming megaprojects, and national economies are becoming integrated into a global economy. As a result, we are increasingly moving outside of the functional parameters of the centralized model along many dimensions, with the ensuing combination of both paralysis and informality within urban systems. We build centralized urban systems, people come, and then they get overloaded. The result is they slowly grind to a halt while also spreading out. Centralized national governments are overloaded and underfunded. Megaprojects go over time and over budget. Megacities become congested and breed informal networks. The critical structural change that needs to come about in this respect is expanding the effective operational range of the model so that it is possible to provide organization along the whole spectrum, not simply cover a small bandwidth in the middle. This is done through decentralization, switching to a distributed model first. Instead of always moving towards the default position of a centralized solution, shifting the paradigm to thinking distributed systems first, and this is now made possible by advances in technology. Distributed systems involve peer-to-peer interactions. This removes the centralized bottlenecks that create the upper limits, and they are able to provide organization at a much lower cost, thus removing the lower limits. This makes them potentially capable of scaling along the full spectrum to provide organization at all levels. Information technology is the critical enabler of these distributed systems. Whereas previously we had to use the centralized model to achieve the critical mass required, information technology now provides the means for overcoming this constraint. IT enables the connectivity and automated coordination required for aggregating the small distributed contributions of many and coordinating them to deliver solutions at scale on demand. This potential is realized through the development of online platforms of coordination. Just as the industrial age had a standardized set of solutions for everything from providing energy to transport to education and housing, which was based around centralized, formal, closed systems, so too the information age has its own core architecture and set of solutions, but these are based around open networks of coordination through information. This means switching from the provisioning of urban services by a limited number of closed formal organizations and instead building open platforms which anyone can plug into and deliver services. Thus, instead of building more centralized solutions, large centralized projects for more highways, power plants, office blocks, more parking space, we ask first, how can we push the resources and capabilities out to the edges of the network and then build platforms for aggregating them to achieve scale as required? Instead of building another power plant, how can we enable people to create their own electricity through distributed generation, building a smart grid platform for exchange? Instead of another highway, how can we build a platform that connects people for them to exchange transport services on demand, peer-to-peer? Instead of more supermarkets, how can we leverage the distributed technology of gross systems and food platforms? And the list goes on. We are trying to shift the emphasis towards modular, scalable solutions with very low thresholds to entry, so that we can harness all of the distributed resources of the end users in the system, toward them providing their own services peer-to-peer. Instead of large, monolithic structures imposed as a one-size-fits-all, the emphasis shifts to asking how can we create small, very basic modular building blocks that people can then build upon and plug together to achieve those large structures in an evolutionary process over time. With the platform model, the emphasis switches to working with people's inherent drives and interests, and the challenge becomes one of aligning their incentives with that of the whole. Platforms create optimal outcomes and value by connecting people, providing them with information so that they can coordinate and achieve optimal results without those outcomes being pre-specified. These platforms are essentially markets for enabling everyone to be a potential producer of value and exchange that directly peer-to-peer. The ultimate aim of user-generated systems is to harness all the resources available in the community. This does not just mean as many people as possible, but also harnessing their engagement along as many dimensions as possible. This requires that we recognize all of the value within the system, every dimension to an urban environment that contributes towards creating a functional living space, natural capital, economic capital, social capital, and cultural capital. The function of the platform is to provide the information resources for people to recognize and develop this multiplicity of value sources that help to make the community a functional one. All of the activities that contribute or deplete from the resources in the urban environment are identified on the platform, and people are given the capacities to create and exchange that value. Already, we have experimented with social networking as one technology that can enable this. People care hugely about their social capital, their connections with others, and this can be harnessed to create pro-social behavior, contributing significant resources to a community. But going forward, blockchain token systems will increasingly be available to manage and grow any resource within a community, enabling individuals to provide services of all kind within distributed token markets. The shift from the industrial model to the information model is a shift from physical mass to organization through information networks. From delivering solutions by creating more things to delivering solutions through more effective organization. This requires us to shift our analysis from the component parts of the city to looking at the whole urban system. Seeing the city as an integrated urban system and focusing not so much on optimizing individual components, but rather the interaction within the entire city as an ecosystem. In this view, the city is an ecosystem of many different interacting parts, and we are asking how we can use information-based platforms to identify those parts and try to build positive synergies while reducing negative synergies. The idea that we can focus on specific areas to optimize for a single outcome has its limitations. Seeing the urban system as an equation of simply optimizing for all of the components results in suboptimal overall outcomes as it reduces the synergies between components. Every component in the urban system should be assessed along all value dimensions that it is adding or depleting from, and how that system interrelates with other components to create positive or negative synergies. When we start to bring a full value approach to urban development, monofunctional systems come to be seen as suboptimal compared to systems that can deliver a multiplicity of value sources in an integrated fashion. A billboard that also works as a seat for people to sit on. A building roof that works as a garden space. An old train track that is revamped as a jogging area and exhibition space for sculptures. A wall that can house plants on it. A pathway that can capture runoff water. Cities that tell stories in their architecture. Houses that double as offices. Roads built out of plastic waste, etc. This enables a multiplicity of processes to take place within the same location, thus removing the need to create a whole dedicated area for them. It works to integrate areas and create neighborhoods, removing people's dependency on going to specific centralized locations for certain activities. When you conduct a full value analysis, these kinds of things start to come to the forefront and change the equation under which decisions get made. In the challenge of city density is also the opportunity for creating multifunctional systems where different processes work to fuel each other. Urban environments can be self-sustaining systems, but this requires local feedback loops between the different components so that they can adapt to each other and create positive synergies. When we separate things, we remove the possibility for synergies and the value this adds. We get a dead-end effect within linear processes that create waste. Information is the means through which we can create synergistic urban environments, in that it enables people, technology, and systems to adapt to each other's behavior and self-organize, without need for centralized coordination. In the world of distributed platforms, patterns of order emerge through the process of self-organization. The emphasis shifts to designing feedback loops that create positive synergies and the emergence of thriving urban ecosystems that are resilient through their multi-dimensionality. The information revolution enables a new form of services economy, allowing us to reconceptualize the city as a service. The world of connectivity we are moving into shifts us away from the economies of scale through centralization and towards economies of reusability through the connectivity that networks enable. The engine of the industrial model was centralization to achieve economies of scale, which meant that everyone could have their own refrigerator, TV, car, house, etc. The result was a mass consumer society. But the engine of the information age is rapid iteration and duplication at zero marginal cost. When one person can create a file and at the click of a button duplicate it many times and send it to millions of people around the planet at virtually zero cost, with those people then reusing it and duplicating it again at no extra cost, then the value is in this reusability. In order to harness this capacity, though, we have to turn physical systems into services by giving them an information layer that makes them capable of connecting into networks and offering their usage as a service. Instead of building a whole new system from the ground up each time, we define existing resources as services and then build networks for aggregating those resources around the end user's needs. Service systems integrate many different components and coordinate them into seamless processes built around the end user. For example, instead of paying separately for fuel, insurance, car, parking space, etc., users can purchase integrated mobility services from a provider who works to bring those different parts together around their specific needs. This service-oriented architecture to urban development is optimized for user-generated systems and the on-demand sharing of resources. People just have to make whatever resource they have available as a service via an online platform. Organizations can then build networks that combine those resources into a finished service system that the end user accesses, typically via a mobile device. As the complexity of our technology infrastructure and engineered environment unfolds, there needs to be a counterbalancing force of integration for the end user, or else their experiences become too fractured and complicated. And this is what service systems offer as they integrate different components around the user through the use of information technology, stitching parts together and adapting them to the specific needs of the citizen. Service systems engender a whole different paradigm in how we develop and deliver solutions. Most of all, they require a relentless focus on outcomes and asking what is needed by the end user. The end requirement of a city is a high quality of life for its citizens. We can then work backward from this, asking what existing components need to be brought together so as to deliver that service. This is a shift from a push model of pushing out solutions to a pull model, where we first gain a deep understanding of the needs and then pull together the resources so as to deliver the service required. In an age of information and the services economy, our urban environments no longer need to be inert monolithic structures with one size fitting all. The city can be formalized as a service, enabling us to shift from the model of mass to the model of innovation. From competition over scarce centralized infrastructure systems to collaboration around delivering measurable outcomes through reusable plug-and-play modular components. Everything that is of value in the urban system serves some function and thus delivers a service. By thinking innovation first and focusing that relentlessly on the issue at hand, we can conceptualize the urban environment as a service and shift from producing more concrete and steel structures to really delivering outcomes and quality of life. The urban environments that we engineered during the 20th century were fundamentally static in their nature. These infrastructure systems were designed for stable and predictable environments. They operate within a well-defined normal set of parameters and resist change. This makes them inert, non-responsive, and degenerative over time. We build an apartment block once and then it goes through a linear life cycle, degrading every year. Today, the combination of a changing natural environment and new possibilities enabled by IT means that we need to switch the focus towards adaptive systems that are able to respond to changes within their environment. The application of information technology to the urban environment is creating the smart city. But we have to ask, how smart is the city? Is it just transferring smartness from citizens to algorithms and technology? Smartness should not be just about technology. It is about making every aspect of the urban system adaptive and responsive. True adaptive capacity in our urban environment would be about things interacting with each other, peer-to-peer, so that they can self-organize to find optimal outcomes. Too often, we use IT for quite the opposite, aggregating data into large data centers, processing it according to black box algorithms, and pushing it out to determine the operations of the city and its citizens without them even being aware of it. The ultimate result of this is in many ways a city that is less adaptive and more alienating. The best cities are not the most efficient ones. They are cities that are dynamic with well-designed responsive interaction between people, technology, and ecosystem. For the smart city revolution to be something sustainable, the smartness needs to be applied in a holistic way, infused into every aspect of the city. This means data and information being exchanged and processed by computers in order to optimize systems dynamically. But it also means ideas and knowledge to make the city something that engages people in thinking and responding to their environment, making them more aware and responsive to what is happening around them. Smart cities should make people smarter. They should be platforms that enable people to create their own ways of life and not just determine their actions according to what an algorithm determines is most efficient. With information technology, we have the capacity to make every aspect of the city adaptive and responsive. But going from a model that is inherently static to one that is inherently dynamic will, in turn, require a change in basic urban design. Key to achieving this will be shifting towards an event-driven architecture for all aspects of the urban environment. Event-driven architecture is very well suited to the loosely coupled structure of urban systems, as it does not require that we define a well-bounded system of which components are either a part of or not. Instead, components can remain autonomous, being capable of coupling and decoupling into different networks in response to different events. Thus, components can be used and reused by many different networks. This enables greater diversity, adaptability, and responsiveness. Event-driven architecture goes hand in hand with the platform user-generated services model in that it is a design approach where components respond to events over time so that modular parts can be pulled together into services to meet the end user's needs at the right place and right time. In the coming decade, we will see the development and convergence of the Internet of Things with blockchain platforms with major implications for the urban environment. With IoT, the sensing and communications between devices and technologies will be pervasive, and when this is coupled with blockchain technology, it can automatically manage the sharing of those resources to build on-demand automated service systems. When all of these architectural patterns are applied to the development of urban systems in a holistic way, it truly is a paradigm shift away from the static, centralized, monolithic, mass, compartmentalized urban structures that we know so well, towards the adaptive, event-driven, decentralized, modular, user-generated, networked urban environment which would provide the underlying structure to remove current stumbling blocks and enable us to move in the direction of a more sustainable process of urban development. To dig deeper into the current rise of urban networks, the challenges and opportunities this presents, you can download the full paper by clicking the link below.